I'd like to review graphing log functions with this example. So once you're comfortable with evaluating logarithms, graphing a log function is really easy. So the first thing you want to look at is what you're taking the log of. So in this case, we're taking the log of the expression x plus 1. And the reason this is important is that you can only take the log of a positive number. So we know that we can only plug in values of x that will make x plus 1 positive. This also will tell us where the asymptote is. So since x plus 1 has to be positive, that means that x has to be greater than negative 1. So we have a vertical asymptote when x equals negative 1. This just divides up the coordinate plane into two regions. The region where we will have points where x is greater than negative 1, and the region where we will have no points where x is less than negative 1. Right, the next thing we'll do is just try to find a couple values of x that make this expression very easy to evaluate. So I see that this is a common log. That means that there's no base written, so it's in base 10. So it would be very easy to evaluate if x is 9, because this would be log base 10 of 10, which is just 1. So if I make x 9, I have log base 10 of 10, which is 1, times 4 is 4, minus 2 is 2. So that means that when x is 9, f of x, or y, is 2. Right. The next value of x that pops out at me as being a really easy value of x to evaluate here would be if x is 0. So if x is 0, I'm taking the log of 1, which is always 0, no matter what the base is. So log base 10 of 1 is 0, times 4 is 0, minus 2 is negative 2. So that means that when x is 0, y, or f of x, is negative 2. So I have these 2 points, and I already know what the shape of a log function looks like. I know the graph will approach this asymptote and then slowly increase over here. It'll get larger and larger. The values of y will get larger and larger. They're just increasing slowly.